Okay, students, today we are going to start the next lecture in which we are going to start about the properties of aldehyde and ketones. We have completed successfully about the introduction and preparation of aldehyde and ketone. Okay, now it's time for properties. So before properties, there are certain two objective questions, direct objective questions. Okay, so what are those two objective questions and which is further conceptual based questions that I am going to tell you. Okay. So the very first point is there is a small difference between the aldehyde and ketone. Okay. Aldehyde is a pungent smelling. Aldehydes are pungent smelling, whereas ketones are pleasant smelling. Okay. Pleasant smelling liquids. There is a pungent smell, there is a pleasant smell. Smell is there, but and both are liquids only. Okay. So question will be why they are liquids. The liquid nature is due to dipole-dipole. Okay. Both contains carbonyl group. In the carbonyl group, this will be partial negative and this will be partial positive. Okay. So because of this partial positive, partial nature, it is a dipole. And because of the dipole attraction force is more. Therefore, all of the aldehyde and ketone are liquids except one. Who is that one? Formaldehyde. Formaldehyde being the smallest member. Even though dipole forces are there, they are not much major concern. Therefore, only formaldehyde is gas, rest all aldehyde and ketones are liquids. Even acetone is a famous liquid used as a solvent, organic solvent. Okay, this is the one objective. There may be question about the smell. There may be question which aldehyde, which carbonyl compound is a gas, formaldehyde. Okay. Second thing is commercially important compound, formalin. Second objective will be formalin. Okay. So formalin is a mixture of three compounds. Mixture of how many compounds? Three compounds. Formaldehyde. So the major compound, active compound used is 40% HCHO, formaldehyde. Remaining 54 to 56% water, and methanol will be mixed with 4 to 6%. When it is 54, this is going to be 6%. When it is 56, it is going to be 4%. This mixture of these three compounds is commercially known as formalin. Okay, these are the two objective, direct objectives. Smell difference may be there, and liquid only gas and composition of formalin. Okay, now let us start with the next most important topic, conceptual topic, that is reactivity order and reason behind the reactivity order. Okay, coming to the next question, next topic, that is reactivity. Okay, for easiness, I have taken three different compounds. This is a formaldehyde, this is any aldehyde other than the formaldehyde, and this is a normal ketone. For here, I am assuming it as a unsymmetrical ketone. Both alkyl groups are different, but they may be same also, not a problem. If they are different accepted means the same will also be accepted. Okay. So the major reactive portion of this carbonyl compound is the pi bond between the carbon and oxygen. The pi bond between carbon and oxygen is the major reactive portion. Okay. So if somebody wants to approach it, there is a lot of space because of the small size of the hydrogen. They can easily approach this carbon, they can easily break this carbon and oxygen pi bond. Okay. But here when it is alkyl group is there, one side is almost, it is covered. Therefore reactivity will be less. When both alkyl groups are there, then it is becomes very difficult for somebody to approach from any direction to the pi bond. Therefore, highest reactivity will be formaldehyde. Second highest reactivity will be any aldehyde other than this, and least reactivity will be of the ketone. Is it understood? And this is about the properties, general properties, introductory properties about the aldehyde and ketone. Now we are going to start with the most important topic, chemical properties of aldehyde and ketones. Okay. Okay, now let us discuss the characteristic reaction. Every functional group, every substance have some characteristic reaction. like aromatic compounds undergo substitution, okay, and which substitution? Electrophilic substitution. Likewise, carbonyl compounds undergoes addition reaction, that to which addition reaction? Nucleophilic addition reaction, okay. So this information every book you will get, but that information, why only this, why addition, why nucleophilic, that is only the main problem, okay. So addition reaction is because of the presence of pi bond between two different electronegative elements. Okay, carbon is less electronegative, oxygen is more electronegative. So the pi bond between two different electronegative elements will be highly dangerous. Okay, highly unstable. So it wanted to remove that pi bond. So in place of that pi bond, we will replace it with the strong sigma bond. For that, which reaction is required? Addition is required. Okay. So why this addition is required? Is it understood? Now, why only nucleophilic? Why not electrophilic? Why not free radical? So for that, obviously the pi bond when breaks, it will be heterolytic cleavage, and this is going to be minus, this is going to be plus. Okay. Why heterolytic? Because of the different electronegativity. Why electron going to the oxygen? Because of the negative charge. Because more electronegative gains electrons, and it will get negative and it will get positive. Now you think about the stability. This oxygen is not a problem because it got octet. Okay, it is not in a hurry to attract somebody, but hurry is with the carbon because its octet is not yet fulfilled. Okay, so this carbon positive is ready to react faster, even though both are available. Electrophile is also available, nucleophile is also available, but calling them by the carbon and oxygen is more for the more urgency is for the carbon. So immediately nucleophile will come over here and electrophile will go here. Okay. So as a result, the product is going to be on this carbon. What is attached? Nucleophile. Okay. And on this oxygen, what will be attached? Electrophile. So this is the product. This is a general mechanism. If general mechanism, if you understand, you will be comfortable. You need not to by heart most of the organic reaction. If you know the reason, then logical questions you will be able to understand. Otherwise, from the book also you can read and understand. Nucleophilic addition, you have to mug up. Okay. Even most of the teachers also what they will say, you have to remember this. Okay. So every word is clearly explained with the proper logic. Is it understood? Why addition? Why only nucleophilic? Addition because of the pi bond, nucleophilic is because of the instability of carbocation, which is further because of the non-availability of the octet. Is it understood? So characteristic reaction of carbonyl compound is nucleophilic addition, and this way it is going to be attached. Okay. So if you understand this, the further examples we are going to take will be very easy. Okay. Okay, if you understand my previous explanation, then it will be easy for you to understand this also. Okay, so Cn will be minus, H will be positive. That means in the general explanation, whatever I written as a Nu, here Nu is what? Nucleophile is Cn minus, and H positive is electrophile. And the pi bond will undergo which type of reaction? Hydrolysis. The electron will be given to whom? Oxygen. So this will be given to this will be minus, this will be plus. So Cn will come and attach here, and H and go attach here. Okay. So there is a most important functional group is formed. Okay. This is a important functional group. Okay. This got a importance because many synthetic. Okay, this is used for preparing many compounds. Okay, and this functional group is called as a cyanohydrine. This functional group is a combination of nitrile, combination of alcohol. If both alcohol and cyanide group attached on the same carbon atom, that functional group is called as cyanohydrine. Okay, it got the synthetic importance. By using this, we are going to prepare many compounds. Addition of HCl, HCN, is it understood? In HCN, nucleophile is Cn minus, H positive is electrophile. Why this H plus will go that side? Why Cn will come at this side? Already clearly explained in the before. Now I am going to explain why this cyanohydrine got synthetic importance. What are the compounds which we are going to prepare, that I am going to explain you. Okay. Okay, as I told you, it is a synthetic importance. That means many functional group further can be prepared by using this functional group. What is this? It is called as cyanohydrine. What it is called as? Cyanohydrine. Okay, cyanohydrine can be used for preparation of amines, amides, carboxylic acid, and further aldehyde. Okay, but one common thing is all of them will be alpha hydroxy. What will be there? Alpha hydroxy. Okay, so here on reduction with 4 moles of hydrogen. So 2 moles of hydrogen will be going here to give CH2. 2 moles of hydrogen will be going here to give NH2. Okay. So sorry, it is beta. Okay. So this is beta hydroxy amine, alpha beta. Okay. This is the carbon on which functional group is attached. Okay. So then coming to here, this is the functional carbon atom. This is alpha hydroxy amide, partial hydrolysis. Okay, so there are two types of hydrolysis. When cn is given with 1 mole of water molecule, it will give you amide, and 2 moles of water molecule, it is going to give you carboxylic acid. How it is, I am going to explain in the next segment. Okay, for time being, anywhere, okay, when you get cn, if it is written partial hydrolysis amide, complete hydrolysis carboxylic acid, and with memory technique I will tell you just now after this. So first partial hydrolysis, it is giving amide, and complete hydrolysis carboxylic acid. Reduction followed by hydrolysis is going to give you aldehyde. Reduction, partial reduction and hydrolysis is going to give you aldehyde. Okay, so because of so many number of functional group we can prepare, that is the importance of cyanohydrin. This cyanohydrin itself is prepared by nucleophilic addition on the carbonyl compound with the HCN. Okay, so because of this, it is very important reaction, especially to when the question is about find A, find B, find C. So these are all things must be completely understood. Okay. Okay, now just now I told you I will be explaining what is the difference between partial hydrolysis and complete hydrolysis. Okay, so this is the cyanide group. Okay, in cyanide group there is only one sigma bond, two pi bonds. Pi bonds are very, very dangerous. Okay, so everybody tries to replace it with the strong sigma bond. So two bonds must be broken. Once two bond must be broken, this nitrogen requires 2%, this carbon also requires 2%. Okay, so this oxygen will go and available as a C double bond O. Okay, and this nitrogen will get NH2. So what is the functional group we got? When 1 mole of H2O only used, it is converted into what? Amide. Okay, but if you are able to give one more mole, then it is well and good. Then these 2 moles is called as a complete hydrolysis. If you give only 1 mole, then it is called as a partial hydrolysis. So I told you sometimes we need to write as a H2O, sometimes we need to write as a HOH. Here we are writing as a HOH. Okay, so this is the memory technique. NH2 plus H, it is going to give you NH3. C double bond O, OH. What it is going to give you? Carboxylic acid. Okay, so carboxylic acid and ammonia, two things are prepared here. Amide is the partial hydrolysis product, and complete hydrolysis you are going to get carboxylic acid. Okay, so it is going to be used in the next chapter, that is nitrogen containing compounds, and before that carboxylic acid preparation also we are going to get. So if you study perfectly in this chapter, remaining two chapters are going to be very, very comfortable. Let us take some time for this chapter, but it is going to save you 100 minutes, 100 to 1000 minutes, and you are going to get good marks if you are perfect in the strong basics. Okay. Okay, next part we are going to study is reaction with sodium bisulfite. Okay, sodium bisulfite, NaHSO3, ITE is SO3. Bi means one hydrogen is left over. Okay, it is basically derived from sulfurous acid. Okay, so if you remove only one hydrogen, then it is called as a sodium bisulfite. Okay, so but for easiness, what I am doing is I am writing it as a H and SO3. Okay, so here H will be positive, SO3 will be negative. This part will act as a nucleophile, this part will act as a electrophile. Electrophile will go to oxygen, nucleophile will go to carbon. This is the product. Okay, but on hydrolysis, again it is going to form sulfurous acid. Okay, what it is going to form? Sulfuric acid, sodium sulfuric acid. Okay, so this OH will be attached here, but in the previous class only I told you it is very dangerous to have two OH group on the same carbon. Okay, so again we are going to get this. Okay, again what we are going to get? Same ketone we are going to get. Okay. Okay, this reaction already you must have studied, but still I will explain from the very basic reaction with the Grignard reagent. Okay, so what is going to be the product? Already it was explained in the alcohols, preparation of alcohols. Okay, RNGX. What will be the charge over here? Mg being metal, it is positive and it is going to be non-metal. So negative. So OR, okay, sorry, positive will be on carbon and MgX is going to be attached on the oxygen. Okay, what it is going to be COR and here what it is going to be MgX. What it is going to be MgX. In this step, what it is formed? OR and on hydrolysis, sorry, it is R. Okay, so carbon is attached with R and MgX. On hydrolysis, H and OH. Okay, oxygen will be with Mg. So H will go attach here and MgX will be minus. So what it is going to give you? R and it is OH. Okay, so better I will explain once again. Here, this is the carbon. On this carbon, alkyl group is there, and oxygen MgX is attached. Okay, H and OH. So this H will go here, and Mg and OHX. Mg and OHX will be eliminated to form OH and R. Already it is there. So already R was there, now OH. So it is a alcohol. Okay. But main problem is we cannot prepare. This method cannot be used for preparing the methyl alcohol because already one R will be there. Okay. So maximum to maximum what we can take, this can be. That means it is primary alcohol. Okay. So we cannot prepare. If it is a ketone, we cannot prepare 2 degree, 1 degree. Okay. Because if suppose R dash, R dash. Okay. So if we use the ketone, we can prepare 3-degree alcohol. Okay. So if it is aldehyde other than formaldehyde. Okay. So then what it is going to be? 2-degree alcohol. If it is a formaldehyde, then what you are going to get? Primary alcohol. Okay. Depending on the type of carbonyl compound, we can prepare what are the things: primary alcohol, secondary alcohol, and tertiary alcohol. I am going to write a list of it, so try to be very careful. This Grignard reagent is a most important topic. Okay, so suppose formaldehyde. Okay, formaldehyde plus Grignard reagent. Gr means Grignard reagent. What it is give? 1-degree alcohol. Okay, any aldehyde other than formaldehyde plus Grignard reagent. What it will give? 2-degree alcohol. Okay, if it is a ketone, plus Grignard reagent, what it is giving? 3-degree alcohol. Okay, so that is the difference between different react carbonyl compound, different type of alcohol. What is the disadvantage? We can never and ever prepare formaldehyde by this method. Okay, so nucleophilic addition reaction, how many examples we have done? We have done 3 examples. First example is reaction with HCN, which gives the cyanohydrin. That is most important. Second thing, sodium bisulfite is not a much problem. Sometimes it will form a crystal. Okay, so that is an example, that is an identification procedure, and this is also most important. Okay, reaction with HCN is important, and reaction with Grignard reagent also important. These 2 things you have to be very careful. Okay. Okay, the most important topic of this chapter, we are going to start reaction with ammonia and its derivatives. Okay, what is the topic? Reaction with ammonia and its derivatives. Okay, but there is a general procedure. If you follow the general procedure, or it is very easy. Okay, so this is used for identification. Okay, in the examination, if somebody gives, it gives 2,4-DNP test. It is a test whether the given molecule contains carbonyl group or not. To check this is a test, 2,4-DNP test. 2,4-DNP test means 2,4-dinitrophenylhydrazine. Okay, so what is that and how it is going to do, that I will explain you. Okay, so mechanism part I will explain you. These are the ammonia, hydroxyl amine, hydrazine, phenylhydrazine, 2,4-dinitrophenylhydrazine, and carbazide, semi-carbazide. Okay, what are those we are going to discuss now. Okay, now but basic reaction is same. So this is the first C double bond O. Okay, and hydrogen, okay, hydrogen and some group will be attached. Okay, this is the general ammonia and its derivative. If it is ammonia, it is going to be hydrogen, some derivative, there will be some other group. Okay, so as the basic fundamental rule, this is going to be the first step. First step is going to be same. Okay, what is that? It is going to give R's, OH and NH and group. Okay, so after that what happens, this water molecule will be eliminated and there will be double bond. Okay, what it is going to be? Double bond, C double bond N group. Okay, so this is the final product we are going to get. Final product we are going to get. Okay, so here this group changes, then answer changes, but all mechanism is similar to this only. Okay, so first let us take reaction with ammonia. First, what we should take? Reaction with ammonia. In ammonia, what is the answer here? This is hydrogen. Okay, and it is going to be hydrogen, and it is also going to be hydrogen. Okay, so these are called as a imine. What they are called as? Imine. Okay, depending on the groups, imines are divided into 2 types, aldimine and ketimine. Okay, imine means amine but with double bond. Okay, so if it is NH2, then it is called as amine, but because of the double bond, it is called as a imine. Okay, so if suppose hydrogen, then it is called as a aldimine. What it is called as? Aldimine. Okay, if both side it is alkyl group, then it is called as a ketimine. Okay, so the reaction of carbonyl groups with ammonia will give you aldehyde or aldimine or ketimine. If aldehydes react with ammonia, aldimine is produced. If ketone react with ammonia, then it is called as a ketimine will be produced, but product will be aldimine or ketimine. Okay, now let us take with the next, hydroxyl amine. So in that, this functional group will G will be OH. Okay, this group is going to be OH. This group is going to be OH. Okay, so oximes. This functional group is called as what? Oxime. Okay, so again they are divided into how many types? 2 types, aldoxime and ketoxime. If at least one place, if it is hydrogen, then it is called as a aldoxime. If both side alkyl group, then it is called as a ketoxime. If both side hydrogen also, then also it is aldoxime. At least one hydrogen or both hydrogen, aldoxime. If at least both side alkyl group, then it is called as a ketoxime. Okay. So depending on the double bond carbon atom groups, they are divided into two types. Okay. If it is H is there, imines. If OH is there, oxime. Okay. Next, if it is next, what I told you, hydrazine. Okay. So in hydrazine, it is going to be NH2. Okay. It is going to be NH2. Like that, if you understand one basic part, then it is hydrazone. What it is called as hydrazone. Okay. So it is hydrazine and it is hydrazone. Okay. So this is how you have to prepare. Okay. Next, coming to what I told you after the hydrazine, ammonia. First part I told you ammonia. Second part what I told you, uh, hydroxyl amine. Okay. Then third one is this hydrazine. Next, phenyl hydrazine. What is the next one? Phenyl hydrazine. In phenyl hydrazine, this is going to be phenyl. Okay. So this is going to be phenyl. Phenyl hydrazine is used, and what is the product? Phenyl hydrazone is the product. What is the product? Phenyl hydrazone. Okay. So see how easy. If you first understand one reaction, plenty of reaction you are able to understand. Even next one is also further easy. What is the next one? Most important I told you, 2,4-dinitrophenyl hydrazine. Okay. So this is hydrazine, this is phenyl hydrazine, 2 and 4 dinitrophenyl hydrazine. Okay. So what you will do here also, you will write as NO2, here also you will write as a NO2. Okay. 2,4-DNP test. What it is called as 2,4-DNP test, where it is used to identify whether the given compound contains aldehyde or ketone. Okay. So they will give what they will give, compound A with molecular formula this gives DNP test. That means you should confirm that either it is aldehyde or ketone. Okay. So 2,4-DNP test is used as a identification test for the presence of carbonyl group. Okay. Okay. Next part is semi-carbazone. Okay. Semi-carbazone formula is actually this is azide. Okay. And it is amide. Okay, this is called as a semi-carbazine. Okay, semi-carbazine on reaction with it is going to give you semi-carbazone. What it is going to give you? Semi-carbazone. Question, there was a previous question and lot of chances are there. Many times it is repeated. Here, see here, NH2 is this side also, NH2 this side also. But always, every time, this nitrogen only involves in the reaction. Okay. Question is that why not this nitrogen involves? Okay. Their answer, what you should write, this is more stable as compared to this because this is in conjugation with the carbonyl group. Okay. So this lone pair, because of the conjugation, lone pair of the nitrogen, this nitrogen involved in conjugation, therefore this part will not participate. But this nitrogen got lone pair, nucleophilicity is only we will check. Nucleophilicity is because of the electron density. More electron density, more will be the nucleophilic properties. Okay. So this nucleophilic properties of this nitrogen is more than this because this lone pair are required by the house member only. This lone pair will be given to one of the carbon atom belong to the same molecule, but it is free to donated. So this nitrogen only will participate. Rest all is very easy. Okay. So reaction with ammonia and its derivatives now I think understood. First let us give a summary. Okay. What is the first part? Ammonia. Okay. So second one is hydroxylamine, NH2OH. Third one is, what is the third one? Hydrazine. Okay. What is the third one? Hydrazine. and fourth one is phenylhydrazine NH2 NH phenylhydrazine. Next is 2,4-dinitrophenylhydrazine NH2 NH, and it is going to be treated with 2,4-DNP. Okay, out of all this is most important, and sixth, conceptually important. What is that conceptual question? Why that other nitrogen will not be involved? Okay, so this is the product. Okay, this is also nitrogen, this is also nitrogen, but always this will participate, this will not participate because of the lone pair involved in conjugation with carbonyl group. And where it is used? It is used to detect the presence of what? Presence of carbonyl group in the given molecular formula. You will be given with molecular formula. If it says does not participate or does not give DNP test, that means you should confirm that it is neither aldehyde nor ketone. If it gives test, it will be aldehyde or ketone. Is it understood? Any doubt about this? Okay, next nucleophilic addition reaction example is reaction with alcohol. These are not under the ammonia derivatives. It is a different topic. Okay, so in alcohol, OR is a nucleophile and H plus is a electrophile. Electrophile goes to oxygen, nucleophile goes to carbon. Same principle applied here. So this goes to carbon and forms as a OR. This hydrogen goes to oxygen, forms as alcohol. Okay, so this can be called as acetal or ketal. Okay, so when it is ketal, if both alkyl groups are there, okay, already R is there, R dash, R double dash, okay, R double dash, R dash, then it is called as a semi or hemiketal, or it is called as semi or hemiketal. Okay, if one more mole of alcohol is used, one more mole of alcohol is used, okay, then it is called as a ketal. Okay, so if both side alkyl groups are there, hemiketal and ketal, okay, this is called as a hemi means half, hemiketal, and it is complete ketal. Okay, so if one is hydrogen, okay, this is R dash and this is hydrogen, this is R dash and this is hydrogen, this is R dash and this is hydrogen. Okay, so this product is called as a semi acetal, what it is called as hemiacetal or semi-acetal. Okay, hemisphere, half sphere, like that, hemiacetal, or you can say semi-acetal also. But in examination, mostly they will use hemi word. Okay, so then if both are, if one OH is left over, hemi. If no OH is left over, both are ethers. Okay, on the same carbon atom, if two ethers are there, then it is called as acetal or ketal. On that carbon atom, if at least one hydrogen is there, then it is called as a acetal. If both are alkyl group, then it is called as a ketal. Okay, so these are the chemical properties. In chemical properties, most important chemical property is nucleophilic addition. Okay, so nucleophilic, and out of the nucleophilic reactions, which is more reactive? Aldehyde followed by the reactivity order of reactivity. I'm telling you, general order of reactivity will be formaldehyde greater than aldehyde greater than ketone. Okay, these are the some important points of the chemical properties of aldehyde and ketone. I think everything is clear now. That's all for this lecture. Okay.